I'm reviewing this scope here from Siglent, the SDS2104X Plus. This particular model is a 100 MHz model. I'm just going to go through some of the other features with you in a bit more detail. If you haven't seen my previous video, which is the unboxing and the first look at the scope and just having a little bit of a fiddle around with it, go and check that video out. I'll chuck a link up in the corner there for it or something like that, or down in the description. I'll link to it anyway somewhere. I only did it a couple of weeks ago, so make sure you check that out. It should be easy to find. It covers a lot of the detail about the scope already. So this is just like an extra bit. So I'm now playing around with the Logic Analyser side of it, and the MSO section here, the SPL2016, which is a 16-channel Logic Analyser add-on. So obviously the benefit of having an MSO scope is that you've got the MSO functionality and Logic Analyser section. Now this is 16 channels I've got set up on here. This board here is a test board, a Siglent test board. You can actually buy these. Siglent actually generously gave me this when they saw me making one to do testing with, so they actually gave me this board, so that's great. So I've got two things hooked up with this right now. I've got the 16 channels Logic Analyser. Thankfully on this one I just plug straight in, it's nice and easy. But you can use hook clips and the other leads and stuff with them as well instead. I could have used hook clips and gone to different inputs. But in this case I just plugged in because it's just easier. I'm a bit lazy. And you can see I've got 16 channels running on here right now. So it's got two buses for doing decoding. That's what's along the bottom here, though, because I'm zoomed out quite a bit, it's all compressed so you can't really see it. So if I get in a bit closer, you can see it's doing decoding along the bottom here. You see the numbers there? Okay. I'll probably change my camera angle actually. You can actually see the different bus decodings that don't come up with the same values. Now, because it's got two buses, I've set this up as two 8-bit buses. So I'm doing decoding on two different buses at the same time. So you can analyse two kinds of digital signals at the same time. So it's quite good having 16 channels, flexibility there. So if we go into the digital section here, you can choose the kind of levels you're going to be using for decoding, or the actual Logic Analyser functions on both channels. Okay, here's the buses, bus 1 and bus 2. I can say change this one to be binary instead of hex, so it's now doing binary. It's a shame it doesn't have a text options like a ASCII. An ASCII decoding would have been quite nice as well, to convert decimal to ASCII in line. That would be quite nice. So your decimal and unsigned decimal as well, and obviously the hex. You can also set the data width of each channel. I've just got it set at 16 for now. And data channels, it's all flexible like that. It's all pretty good. So if I do a 16-bit, if I do 8-bit wide channel and set the data and tell which channels to use. So this is using bit 0 is on D0 up to bit 7 on D7. Okay, that's what that bus is using. And bus 2, I'm sure I had these both set at 8. Data is using D8 through to D15. Okay, so that's the other section's got 4 there, 4 here. Well, so 8 there, 8 there, which is off each of these heads. Okay, so you can change this around, you can change the order. If I wanted to make that a different channel, I can make it D14 instead. It's just tap on it and change it, so D8 again. Right, so that's how that's done. You can turn displays on and off, obviously, so you don't want both there. You can also move them around, so you can position them on the screen wherever you want. So that's quite handy too. And you can do it, obviously both channels identical. Now also I've got the channel 1 set up. Show up on here because I'm zoomed out quite a bit, or zoomed in quite a bit, it's not really going to show up too well. But there you go, it's just doing a UART signal on that one. It's doing a PWM, I think that's what it's set to. So let's turn the digital off. Now you notice here that now digital's not showing up. So what it does is it indicates which one you're controlling currently. So I've got some on digital zone now, that's controlling digital circuitry. If I do that one, I'm controlling the analog channel 1. But I don't actually like that completely. I mean, if you go to channel 2, for example, channel 2 is now on, though you can't see it. I do like the coloured buttons though, that's really nice. And so you can see which channel you're controlling, so that I don't mind. But I wish you could actually see at a glance which channels are turned on. So what I think I'd prefer Siglent to actually do with this is to have it say if the channel's turned on, it's eliminated. And if that channel is active, maybe it blinks or flashes or something like that, it just pulses, so you can see the active channel which you're currently controlling. I think that'd be a better way of doing it, so that way you can see at a glance what's turned on and which one you're on at the same time. That's obviously doable in firmware. Maybe Siglent will see this video and go, oh yeah, that's not a bad idea, and implement it. Who knows? I know they do watch my videos from time to time and actually check out my suggestions too, so hopefully they spot this one. Okay, because originally I thought I had a fault where the indicator was going off when I was changing things around. Suddenly, oh, the digital's not on, but actually yes it is on. And it threw me a little bit, and I realised what it's actually doing. That's just the way it works, it just shows you which channel you currently selected. Nice, turn channel 2 back off again. Let's turn digital back off. So now I've got no channels on. This channel 1. So we need to do some triggering on here. So let's go trigger menu. We want to trigger off, we were triggering off D7, now we want to trigger off analog channel 1. And here we go, it's channel 1 triggering. Now I've got a hold off time on here, 1 second. I did that on purpose to slow down the display so you could see what was going on. So I'm actually going to turn that off now, don't need it. And now we can see the jitter in here from the PWM. This is PWM input. And if I change the signal to a different type, this is now doing a burst. This is doing a glitch, and this one is doing a slope change, and I don't really know if you can see it in there or not. These slopes here are changing. Just see it flicking. If I could put persistence on, you better see it a bit more easily, but I don't think it's really necessary. This is a runt pulse, which is in there somewhere. You can just see it flicking up sometimes in here. So what I'm going to do is go into the triggering. I'm going to change it to a runt pulse. And it should hopefully find it in there somewhere if I get the trigger level set right too. Here we go, there it is. There's the run pulse. That's triggering on that just fine as well. That's all what it's supposed to be. It's a quite responsive scope as well. It's quite fast to respond. It's pretty good. Now the acquire menu memory depth. If you shorten this time up, I've got it set at 2 megasamples right now. But the faster you go, the more responsive the scope is, right? Because it's not storing less memory in there, and it's got a bit less thinking time required. Obviously it doesn't affect it much, but it depends on what you're actually working on. But I did see some differences between doing a larger memory depth and a short memory depth on responsiveness on the display. It was changing very slightly. It was a little bit snappier. It's about 10-bit as well. So some other things in there. I was looking at display menus in here, and this does scroll. You also got LED lighting, so you can actually adjust the lighting brightness on the front panel here. It's kind of 50%, and you know, you can select everything basically. If you want different grids, you can change those. There's 3 different grids there. Personally, I prefer that one all the time anyway. So LED lighting, let's see if I can do it this way. Turn it down. You might see it just sort of dims out quite a bit and comes back up. It's not a huge change. My lighting's washing it out as well, so I'll just say generously with 50%, and then you can see it. Yeah, like red numbers. So that's that part of it there. I've already showed you this acquisition stuff. I've been playing around with these acquisition modes a little bit. I couldn't see a huge amount of difference, but maybe it's just the things I was playing with that didn't really matter that much. Not too critical. Is there anything particularly you want to see on this scope? I mean, I don't know. I've already covered so much with it. So bus protocol. So I'm using UART right now on channel 1 to turn it on, and it's also got 50 ohms and 1 mega ohm switching. Also change the display from volts to amps, because if you know what sort of probing you're doing. And my probe is currently set to 10 times. Maybe I should show you the probe compensation, because I don't think I've videoed that ever. Now when you get a scope for the first time, you do probe compensation. Now it may not be obvious to people which are just getting one for the first time, then it's new to them. Although I'm not sure if a first time user would get this particular scope, because it's a bit more advanced rather than the other ones that are out there from Siglent. So let's stick that on there. And technically you don't need to set the ground on as well, but there we go. There's a pulse there, right from the calibrated output there. So as obviously I've already done the compensation on this one. And in the probe pack you get a little screwdriver just here. So to do probe compensation, there's a little hole on the side here. You set your probe to 10 times like that, and you see there's a little slotted hole, well, the hole with a screwdriver tip in it. Sometimes in different places, sometimes it's actually on the jack itself, on the actual connector. Depends on the probe, but this one's actually on the probe itself. Sometimes it's over here instead. Anyway, you hook that up to the cowl point for setting up the probe. Hook this up onto the ground as well, though it's a shared ground, it shouldn't be matter, but it's just good practice. And we're going to set this up. As you can see right now, it's actually set quite nicely. I've got quite a big waveform on here, so I can see really easily, and you can see really easily too. And I'm going to misadjust it first. So there you go, there's an undershoot. And I'll slip that slot, there we go. Overshoot. Okay, so you shouldn't have either of those. Often when you get the probe and you use the scope for the first time, you might find that it's not set correctly for the scope input. And that's just only a minor thing. You just do what I'm doing right now, hook it up and just tune it. Okay, so this screwdriver comes in the set with the probe, so it's not exactly hard to find. It's an insulated screwdriver, so it doesn't have an effect on the capacitor, because this is the tunable capacitor inside the probe. And we'll tune that and get a flat line across there, as flat as you can on the positive side and negative side of the waveform. Alright, see it's getting a bit fuzzy there. That's going up a bit. That's going down a bit. Okay, so let's bring it in the middle of those 2 points and try and get both sides as good as you can. So I think that's a good compromise there. It's got a little bit just on the bottom, but the top's looking pretty good. So let's just change voltages on here. That's looking alright. Also change this as well. This kind of exaggerates it, but generally as long as you've got a square wave on the screen you can compensate properly. So the probe pack on this as well, I should probably talk about this too. So you've got some coloured colours in here for the probes, so you can code your probes to match your scope inputs. You've got a BNC adapter here as well, so you can stick it on your probe and plug it into a BNC port. And you've also got a short ground clip as well, or ground probe, so you stick that on the tip of the probe if you're doing high frequency measurements or really critical measurements. You can it minimises your ground loop, which can be really good for getting more accurate results for your probing. So I thought we should also have a look at the booklet for the probes so you can see what the detail is about these things, information on them. There's typical response curves, and it also tells you about how doing the probe compensation. I've just recorded a bit of footage on doing the probe compensations. I'm going to make that a little standalone video as well. And you've probably seen a bit, I've just probably included already, showing how to do it. So it tells you how to do it on here just very briefly, but hopefully my video is a bit more clear. So it also shows you the derating as well for the voltage versus frequency. So the higher the frequency, the less the voltage the probe can handle. This is rated at 200 MHz, and it tells you the bits that come in the pack. As was fairly obvious standard stuff. Anyway, if you're familiar with scopes, you'd be noticed anyway. But here's the specs on the back there. Rise time 1.75 nanoseconds on these probes. 100 volt IMS Cat 2 at 1 times and 300 volt IMS Cat 2 at 10 times. The scope input itself can handle 400 volts peak with 1 mega ohm 7 MPF input, or 50 ohms less than 5 volts RMS peak. Which this cable's in the way, you can't see. Alright, just down there. So depending on which input resistance you have on your impedance setting, you can have 1 mega ohm or 50 ohms, and so that's 400 volts or 5 volts. Quite an important thing to make a note of. You don't want to chuck a high voltage in this thing when you've got a set of 50 ohms, because that could be quite bad for the front end of the scope. So compensation range 10 pf to 35 pf, not like you really care that much, and knowing most likely, and also your packing kit of all the bits that come with it. It's a scope probe. Right, so let's play around with some other stuff. I've turned some of the lighting off just to try and make it a bit easy to see things. So other touchscreen functions which we should probably cover. Right now I'm feeding in a UART signal off the Siglent test board just here, and that's spells out Siglent and some other characters at the end there. So I've got quite a long hold of time on this. I've got 258 milliseconds on here. I'm just using edge triggering, falling edge, so I can catch the first downward pulse. Right, you can see I've got the trigger set to the left. A few things we can do here when it comes to triggering. So you've got these little tabs that appear on the bottom here, these little panels I suppose you could call them, and they are adjustable. You can touch on them and you can bring up stuff. Auto triggering is what I'm on right now. Also going to do single and stuff like that. And set this 50%, and you can also adjust trigger levels. The same thing you can do on the front controls. Now time base, you can do the same sort of thing here. You can zero the time base. I've got a delay of 19.2 milliseconds here. What it does is it's shifting it over to the left. Right, if I zero that, it will go to the middle. I can also do left, which puts it over here, and right, which puts it over here for the trigger point. Okay, so it's nice and convenient. You have to scroll around trying to do stuff. You can just tap that and it's in the left position. And a lot of times when you want to do triggering, you actually want it to be to the left side quite often, because what happened before the trigger, sometimes you're not interested in that. What you're interested in is the trigger point onwards, especially if you're doing serial communications, you're trying to read the serial packet. Having a left align is quite nice. Time base, you can adjust the time base in here as well. It does have fixed values, and stepping up and down just like the horizontal position over here does. No different there. Over here we can do channel 1 selection here, and you've got scaling, and you can also do your coarse scaling, which is selected by default. Now you've got fine adjustment, so you can actually adjust this in a fine resolution. Okay, if I do it by the control over here as well, this is now in fine mode. Okay, so I'll go back over here, put it back in coarse again. And you also got the offset position and stuff like that, and zeroing, so you can center it. All the standard stuff. Copying and fast apply too. I'm not sure what these do yet. Menu, that brings up the channel menu, same as pushing that button really. A lot of these on-screen functions are the same as pushing the buttons or variations of that, but there are some features in there which aren't as accessible. Let's push that one. Anything? No, nothing there. Let's push this. Select to add, so I can add other channels on. functions reference. So let's put the digital channel on there, and now it's turned the digital channel on. So instead of pushing over here, you could do it on the touch screen and turn it on. Just different ways of achieving the same thing. I suppose it depends on how you want to use it, really. So in the decoding menu, so I push this to go to the decode menu, and result list. Let's turn this on bus 1, and that will then put in here the results. Now the only problem is with this, I don't think it's a problem really, it's more of a design, the way I've designed it. I mean, you can scroll through and that sort of stuff, but the limitation is 7 lines. You can't do more than 7 lines. They obviously decided at some point that up to 7 lines is all you actually need to see on screen. Well, you've got this massive screen, there's no reason why you couldn't have 10 lines or maybe 16 lines on here, and then you can actually see the data a bit more easily in a list like this. I'm not sure I'm a fan of that limitation. I think we should allow you to have as many lines as you choose to have. So maybe Siglent should consider changing that if you see this part of the video. And scrolling, so this allows you to scroll up and down the list. Although it's a bit, because I've got a thing triggering all the time. Let's turn the triggering off. Do a single capture. Then I can scroll the list a bit more easily. It will just go through. Now the Siglent do have this thing where, to me, when you turn a knob clockwise, that's an increase. Siglent have turning knob clockwise as a decrease and anti-clockwise as an increase. I'm not a fan of that. They all do it. It's just the way they set their scopes up. If you think about the left edge of this going up and down, and then that goes in line with this, all right? That kind of makes sense, but you know, it's just, I prefer that to be positive, that to be negative. Anyway. Now the other interesting thing I've seen here is that when I've got the list view set, a lot of the time you don't see the first packet. Okay, so the list starts at the packet number 2. Well, you can see the packet number 1 is over here, it's being sensed, but when you look at the list view, it's missing it. Scroll, can I do to number 1 there? See there, I can do number 1. Right, so I can do 1 in this list view and get it that way, but I can't seem to do it from the scroll bar. Now scroll down, back up. So it looks like there's a bit of a quirk here with the list length. Don't know what it means. Anyway, so it's missing yes again. So is it because it's re-triggering at the same time and it's forgetting it because it's loading more data in, or I don't know, but if I do a stop, can we then get to it? No, it's not there. But if I do the scrolling, it's there. So it seems like there's a bit of a bug here with this scrolling of the list where it won't go to number 1. Yeah, inconvenient. I guess we'll have to fix a little bug. But you're going to find little bugs. I mean, it's a completely new user interface. There's stuff here which is different. You know, it's not that surprising you find little things like that. That's part of my testing process, to try and find little bugs, just by doing weird things that other people probably wouldn't do, I suppose. You know, because just poke around and see what happens, really. Things like this will show up from time to time. And system settings, sound. Turn the sound on and off. Languages, let's have a look in here. These are variable languages for it. So what do you have? Is it Chinese, Japanese? Or 2 versions of Chinese, is it? I'm not sure. It look too similar for that. Is that Japanese? Dutch, Spanish, Korean, is that? Or Russian? Well, that's Portuguese. Is that Russian because it's got backwards characters? I don't know, I'm not a linguist. Screensaver. I/O ports here, we looked at that sort of before, didn't we? Actually, hold on. What's this system status? Here we go. Specs about the unit. Hardware revision 2. Interesting. So obviously had a previous version. They've done a change already. So I thought I'd better show you this too, since it's got these features built in. So under the analysis tab up the top here, you'll search, navigate history, decoding, mask test, Bode plot, power analysis and counter. So that's measuring the frequency there. Although we've got over here as well, anyway. Okay, what else have we got? Power analysis. Power quality testing. There you go, whole bunch of options in there. Current harmonics, inrush current, switching loss, slew rate, modulation, output ripple, turn on, turn off, transient response, PSOR, whatever that is, and efficiency. That's nice. Signals, channel 1, channel 2 for voltage and current. Period, I guess that's like 5 seconds or something, I'm not sure. Connection guide, which tells you how to set it up. Look at that. That's nice. Wish they'd actually fitted it all on the screen so you have to scroll it though. There's enough screen real estate, they could have made that fit. So if I looked at, say, efficiency, does that say how to set up as well? Connection guide for efficiency? Yes it does, it's got these little guides everywhere for the different configurations. So differential probes, so it's all isolated. I've got one differential probe, so maybe I should get a second one for something. So what else is there? So Bode plot. Because it's got the built-in AWG, you can use that for Bode plot measurements. Operation, turn it on. Fail to connect to AWG. But it's right here. Okay. Oh, interesting, I can't turn it on. That's interesting. Do I have to use an external AWG for that? Well, that's interesting. Turn it on. Files connect to AWG. Okay. So I would have thought they'd be using the internal AWG instead of using the external one. Because Siglent do make an external AWG. I forget the model number of it right now. But I've looked at it previously with another scope. Was it the SDS2104X was it? Something like, I can't remember now. I did a previous review and I showed it all then. So it looks like this is expecting the external AWG, not the internal one. That's the way it appears. Interface USB, interface internal. Ah, here we go. Let's try that one, shall we? Ah, there we go. Right. I had to switch over to internal manually. I would have thought by default it should be on the internal one because it's got one built in. Anyway, this is going to be a weird result because it's not actually connected to the AWG. Maybe I should hook them together. Anyway, so that works. It's just a bit confusing the way that it didn't have a default setting to the internal AWG instead of using the external USB option. So what other options are there? Also got LAN as well. It's interesting. So sweep type, simple, linear, frequency center, 10 kHz, 50 points, 50 ohm load, so switching the input impedance. Yeah, so other place because it's measuring currently. This test board will just hooked up doing the UART signals. So it's complete gibberish, it's not a proper test. It'll be interesting to see what it comes out with actually. And just the levels, logarithmic scaling, phase checks, yep, degrees and radians, auto setting, obviously cursors. So you can set those up as well for doing measurements on screen. Trace visibility, turn things on and off as you require them. Obviously I've only got one channel hooked up, but it's trying to measure a couple of things at once. Data, you can save it. And measure. Oh, there we go. A bit of information about how to use it. Cool. I really like the touchscreen on this thing. Touchscreen's brilliant. I'm finding it much more natural to use it rather than trying to push buttons and stuff over here. Although a bit of both is, you know, obviously required at some point because sometimes it's going to go bang rather than trying to touch it on the screen. The touchscreen interface I'm getting quite comfortable with. I like it. Some people said they don't really want touch screens because they, you know, they're things like, you know, end up with jam on the screen. Here's one quote I had from Chris. Doesn't like them because he ended up with jam on the screen. So obviously he's having jam sandwiches or something when they're eating. Yes, we'll let this thing finish. Oh, it's got to the end and it's like it's looping back and doing another pass. So yeah, it's produced gibberish, which is what I expected because I'm not doing a proper test. Anyway, so yeah, that's there and it seems to work. So just turn it back off again. Bode plot, I don't know how you want to pronounce it. Well, when I did the first video on this thing, I didn't actually get many people asking questions about, well, I didn't get anyone really asking questions about features for it and things to check out on it. So I don't really have any specific things to address as far as what to look at. Nobody asked for anything specific. Just some comments about the touchscreen basically, that's basically what I got. You know, some like it, some don't. I like it myself, you know. I think it's a really nice scope. You know, newer generation. I like the big screen, it makes it a lot easier to see. My eyesight's starting to go, I think. So it's a bit concerning. Things are starting to get a bit blurry sometimes. So yeah, I think it's time to Anyway, big scopes. Big scopes are good. I think I need one like a screen light. I don't know. That big. That'd be good, eh? Scope that big. Oh my god. Mind you, probably plug an HDMI or something, couldn't you? Well, there you go. There's a bit of a slightly deeper dive on the features of this scope. If you found it interesting, give us a thumbs up. So, now there's only one thing left to do. Let's take it apart. So the first challenge is obviously the seal, the Siglent sticker here. So you make sure people don't go into it without, you know, proper precautions and that sort of thing. Yeah, well, let's just, you know, fix this problem, shall we? We don't want that. We don't need this on here. Okay. We get just the right angle to get it through the adhesive only without cutting into the sticker and without cutting into the plastic. And nice and gentle, she doesn't rip anything. And we are in. Just like that. Now, let me get some tape. Okay, that's tape applied, fold it back out the way. That stops it from getting stuck on other things or folding back over. Now, let's get the screws out. What we got? These are not Phillips, these are something else. You can see in here, hopefully I can get the lighting right and everything. It's probably a Torx, but it's quite a deep one. Let's see if we can get something which gets in there. So my first call was my iFixit talkie here. It is, I think, a Torx 9. I tried an 8, but it's, because they're in these quite recessed holes, only this driver would fit, but that's the biggest Torx this one's got is a Torx 8. So this set won't work. I need to keep looking. Let's try this toolkit. Another iFixit one, which was given to me for free by iFixit. They sent it to me for review. And I did that a little while ago. I did a video on it. So let's try this kit. It's got the same screwdriver, but it's got some extra bits in it. Let's see if I can find one. What have we got down here? Let's try a 10 first. There's a 10 there. There is a 9 as well. Let's just try a 10 first. Yeah, it's a 10. Torx 10. There we go. That's the one. Thank you, iFixit. Now, because this scope isn't mine, and I'm going to take a few extra precautions. Normally I wouldn't worry about an earth strap. Okay, I've never had a problem with not wearing one because my bench is earthed. I'll touch this frequently when I'm working on things. So, you know, this anti-static mat and that sort of thing. So I do already have precautions in place, but I don't usually wear wrist straps to find them a hindrance. But as I'm not prepared to take a risk on somebody else's gear, here's a wrist strap on. I've already taken off my watch as well and my ring, so there's no metal contacts to short things out as well. So I'm going to be doing this the right way, as we should. So let's get these screws out. This one's almost out. So I'll walk around these. I do like this screwdriver set. It's a really nice set. So I'll keep the big kit on my bench all the time. Just a shame I didn't have the right size bit in there for this particular instance. But that's okay, it happens. Kind of it all. I think the bikes are merged too. Down the shelf down the bottom. There's a mod shelf down there, the cups on it. And there's probably some more screws up here somewhere. Right, there we go, hiding under here. So I'll get these out as well. I'll get my little magnet tray. All the screws can go in there. I'll come out in a minute. So the screws on here are actually Fed taped. There you go, get it in focus. So obviously metal screws go into a metal frame, not into plastic obviously. 4 more down the bottom there. Almost got there. I'll come back. Right, so the screws out, let's try now. Oh, got feet dropped out. Must forget to put those back in. There we go. As expected, fully shielded. Right, so a quick look over here before we start putting anything else off. So it's all fully shielded. We've got a nice bolted earth connection there, straight off the socket. All heat shrink down there. You see in there, it's all heat shrinked. All loomed as well. This has got plastic sleeving over these cables to help prevent rubbing on the chassis. Chassis has actually been folded over, so there's no hard edges. Nice little details. So first let's have a look at the power supplies, get into here. Put these ones out in a different place than the others. Just going to see what the power supply looks like. Was out, wasn't it? Okay. There's the shielding. So, do we have any branding on the power supply? We do. It says Siglent. So, it looks like they've done their own power supply rather than off-the-shelf unit. Maybe that'd be useful for someone one day. Give a close-up shot. Lots of gunk in there to hold things together. Stop them vibrating and moving around or being stressed. Isolation slots, auto isolate obviously. Couple of big caps in there, as you'd expect. Looks nice enough. Lead free obviously. So we can see the power coming out through this loom here. So we've got a few different colours on there, so I'm thinking it's probably a multi-voltage power supply based on that. So we'll take this shield off next and see what's under there. I imagine it's using the same screws throughout. It's a good bond technique, reduce the bond costs. These ones have the thread lock on it though, the blue thread lock. I probably won't take this side off, we'll see what it looks like. So I've got the fan here, I'll have to unplug that. Try and wiggle that out of there, there we go. Now it's just going to pop off. That seems pretty solid still. Am I missing something? It could just be a good fit. I'm pretty sure that's all the screws. Double checking before I start yanking on things. I think it's just a really tight fit. So let's get in there with a screwdriver and get that a bit of a lever up. And we'll pop it off. In fact, I've got my tweezers here. These will probably just go in these slots. Right. Yes, it does. Cool. It'll just work. Just leave it up with that. And down here is going to be a bit trickier. There's a slot here I can probably grab hold of. I'm pretty sure that's loose. I'm not completely convinced it is. That doesn't want to come up this side. I think there's a screw. Oh no, that's riveted. Okay, so yes, this is one panel. Those are riveted through in the back here. So you have to take the whole panel off in one go. Okay. Guess it will be coming off. So I'm guessing that I'm going to have to take these nuts off these posts here. Those will be on the main board obviously, so I'm pretty sure I'm going to take those nuts off so I can lift this off here. I think then I've got to take those couple of screws out. I think the whole thing will then come off. So let's stick my probe back in again. Make sure I'm grounded again. So I just have to go and get these pliers because I don't have a I don't driver of the correct size here with me. So I have to use this to get these undone. There we go. Is that going as well? It's probably like a standard socket size, you know, deep reach socket. But I don't have any deep reach sockets in here this size. Of course, smaller ones, but not these. So that's all right. We'll just do this. I'll come back once I've got this off. Okay, last two screws. I'm pretty sure this is just going onto the chassis piece here. Let's see if I can move it. Well, it's looking more promising than it was last time. Looks like it's going to lift off. I'm not actually levering very hard, just very gently. I don't want to stress anything in case I've missed anything, you know. Just very gently lifting. There we go. I think this end should just come out now too. Right. Oops, and I've got to unplug the power supply. Let's do that. There we go. Right, that's the cover off. And we are in. So that's that part. Put this to one side. What a beauty. Very nice. Right, well, let's have a look around. I've just taken a whole bunch of high-res photos. I might put them on my website or something like that, or I'll have a copy of them anyway. So if you ever get stuck, maybe I'll be able to give them to you or something. Anyway, so I've got a few interesting headers. I've got a header over here, which looks like a I2C data bus. We've got another header over here, which looks like stuff for the lattice FPGA. There's some headers up the top here. We've got a serial header right here. Right there, serial header. And some other stuff here as well. One of those as well. So I'm guessing that's for these FPGAs. Right, so that's something I wouldn't be messing with at all. So obviously got both the front end setups here. So both screens, as they're going to be in here, which are soldered shut by the looks of it. Oh, actually no, yeah, those are cans which can come off. You might pop one of those off and have a look. So obviously then you've got the processing side of it all over here. So this is shared per channel obviously, so one pair there, one pair here, which is why you get that drop in the data rate stuff from it, because it's shared between them, as you know, that's commonly done. So you've got obviously the main logic over here. This is the AWG section in this area over here. The port is actually right there, it goes into these relays. So this is obviously for the AWG section. Power supply here, power supply over here is the buzzer, obviously Ethernet stuff, display section over here. So there's a lot on this board, there's a lot going on. So I might have a little pop to see if I can get one of these cans off and have a look underneath. Lift the skirt up, as it were. Alright, let's have a go. I've had these tweezers for like 30 years. Brilliant tweezers. Make pliers and everything. Try and get under here. Pop this up as well, try and get it straight. Come on, lift up straight, you bugger. There we go. Oh, what's going on here? Come on, come off. A little bit more. Stuck in that channel between the two cans. Come on. There we go. Right. Let's have a close look inside here. So this is where the magic happens. There's the jacks just there. I'm not going to touch anything with my fingers inside, obviously. A few relays in there. One will be loading 50 ohm resistor across it for the impedance switching. There'll be some front end tuning, obviously. There may be some electronically switched control of the input as well. These have a bandwidth upgrade to 200 megahertz. So there's a good chance that there's some stuff in here which does switching of that bandwidth upgrade, rather than a relay. Could be electronic switching. There's a lot going on in there. Obviously the other can will be identical kind of setup. So let's see if I can get any closer than this. Sure I can do better than this. Okay, I've got my Andon style microscope set up. Let's have a closer look with that. Obviously some things won't be in focus because of the distancing. Got to be a nice close look. It's really a little bit too close, but it gives you a really good look inside. You can see the part numbering. Brilliant. Perhaps someone wants to have a close look at this. HC595. You all know about those things. So let's try and go down the middle. Capture the other edge, a bit which I didn't really show before. Trying not to miss any bits. So there's a relay again just there. And up the other side. And finally down this edge. There's an unpopulated capacitor right there. Well, I'm presuming it's a capacitor. And another one. Unpopulated resistor. And another one there. So maybe that's front end switching stuff. Another one there. That's probably more likely actually. Cool. I think that's it. This channel's a bit close really. Could done with being further away. Obviously the other channels be exactly the same. And this is literally as close as I can get with my camera with this lens. Can't get any closer than this. So there's a direct shot there. And try and tip it and get different light angles, stuff like that as well. Would you got my lighting reflecting on things? There you go. And we'll try and get some over there too. Try and get to that darker spot. So perhaps someone wants to have a closer look at this front end. Let's put this bad boy back together. Put the shield back in. This could be interesting because it's a bit of a tight fit getting in that gap there. Wasn't happy about coming back out. Oh no, that's going in. That's alright. Easy. Certainly easy to get back together than it is to get it apart. And I'll reverse the process, put it back together, and go from there. These things are tempting to take one of those off. I'm not going to go there. I mean, obviously these are strapped on. Yeah. I'm not going to disturb it too much. Don't forget, this isn't mine. Don't want to risk damaging it. So yeah, put all the screws back in again. Now the casing on this is actually a really nice fit. You've got some nice details on there, like on the casing over here, on these jacks for the RJ45 and USB. There's actually some metal fingers on here, so it actually contacts between the back panel and the shield of the connector. So it's a nice little detail that. And even just the fitment of this onto the outer frame, it's a really snug fit. So it's actually got really good contact all the way around. So it's not like a loose fitting like that, which you know could be there, but it's all nice and solid. It's good. So I think they've actually made quite a good design on the chassis here. Seems like it's well engineered. I haven't seen a single thing which has made me worried. You know, or you know, even sort of re-evaluate things, or as it were. You know, it's all looks good. I can't see anything here. I'm hardly an expert. I mean, I'm not an engineer. You know, I'm just a self-taught hobbyist like most people. I just like to fix a lot of things and work on test gear. So I've had a lot of high-end test gear pulled apart. Well, old high-end test gear. This is like the most modern thing I've touched actually. So yeah, it's pretty impressive inside, I have to say. Pretty impressive indeed. Now the question is, do I end up with any extra screws at the end of it? I hope not. See more left here. Just got to put on the nuts for those connectors for the back, for those BNC jacks. I could probably skip this bit, but I don't know, maybe someone wants to see how it goes back together, so I thought I'd keep it in. Got the BNC jacks, we've got some lock-proof or shake-proof washers on there. Put those on. Get the nuts. Now I wonder if I should actually loosen the screws off so the chassis has got a bit of flex in it. When I tighten those down, that way it's not pulling on the circuit board in case it's sitting up a bit high. Let's do that. Using the proper spanner would have been best for this, but that's what I've got for now. That's tight. That's tight. Great, I'll do those screws up again. Okay, let's put the shield back onto the power supply. Also must forget to plug in these cables once I'm done. Don't forget to do that. So it sits over there like that. This one will drop on inside through one of the holes in the casing. I have to pull it all apart again. It's annoying when that happens. So Siglent's been making some better and better gear. I mean, they've been around for a while now, and each time I see something new of theirs, I'm even more impressed. They're just getting better and better all the time. And one other thing I've noticed is no trademark Siglent rust, as Dave would put it. That's probably because it's a aluminium chassis, so you don't get rust on aluminium, do you? Anyway, but yeah, it's good. The quality is really good. I've been really happy with Siglent. I mean, I purchased my own Siglent gear as well. I bought Siglent myself because I've been happy with what they've done, especially for the price brackets you're in. The pricing is really good. So what you get for bang for your buck, it's excellent. I'm not just saying that because I'm a Siglent fanboy. I'm saying that because that's my experience and that's my opinion. So you can disagree if you choose to. That's fine. Let's get it all tucked down like it's meant to be. I think it's supposed to be tucked out of the way. That side was it? It could have been the other side. That's fine. It's tucked out of the way. So that's down. All the screws are in. No spare screws. That's always a bonus. Don't forget the merch. And let's put the back cover back on again. Right, let's get this in. It should just drop straight on. Now I've also got to put those feet back in. Don't forget these. I should just sit down like that. Now this should all just pop down once it's all aligned properly. I think that's down, I think. Just about down. This side's sitting up slightly. Stopping this side. Is there a clip or something? There we go. Just needs to be aligned that way a little bit more. Okay. Let's get some screws in this thing. This side did come apart quite easy when I pulled it apart, so I think it's just an alignment issue with the casing on the front. I might double check actually before I put some screws in. Okay, it kind of clips once you got it down so far. Actually, it does go clunk. You get a bit of a squeeze and it pops in both sides. So it obviously does have some kind of mechanical latching on there. And yeah. So let's get some screws in, hold the thing together. Two left. Excellent, no spare ones. Okay, check the feet still work. They do. That's all good. Let's put the seal back on. Here's the back of the blade. Don't push the top edge, that'd be a bit dumb. There we go. Good as new, you never even noticed the pin opened up. Perfect. So, she's back together. Phew! Time, as AVE would say. Say. Yeah. And I suppose you want to plug it back in again to prove it still works, eh? Yeah, fine, let's do that. Let's get a power cord. Now this little button here, though you can't really see it on camera, it actually glows green. When it's off, it doesn't, like a lot of my other gear, my Siglent stuff, it's got like a heartbeat, it just pulses on off, maybe a couple of seconds or something like that. Not quite sure the break, probably 4 seconds. But this one just sits there dimly lit green, you can't really see it in this lighting though. Hey, still works. Yay! What will be pleased? Nearly there. I did stop recording whilst it's booting because, you know, save some time. And there we go, we have a trace. It still works. Hope you found it interesting. I'll catch you later. Don't forget to subscribe, click the bell icon, all that usual stuff. Thumbs up. Don't forget to give us a thumbs up. Share the video. People might be interested in seeing the particular scope and those close-up views and inside, that sort of stuff. Make sure you share it. Catch you next time. And check out future videos. You know, subscribe. I do lots of things like this when I get the chance. Bye. Also, if you're a manufacturer of another brand, I'm always interested to look at other stuff, see what's out there. Now it's also got decoding. It's got two buses for decoding. That's that bit. What's the one I showed you on here yet? I don't know, but it's I don't know. I'm waffling again now.